Algebra students, we're going to go over lesson 3.6, which is our third way to solve systems of linear equations. If you recall, the first method was by graphing, the second method was by substitution, and the third method we will cover today is by elimination. Okay, they all have their strengths, they all have their weaknesses. It just depends on the equations that you are given and what they lend themselves to, which process they lend themselves to being the easiest to solve. So first thing we need to look at are the steps involved here. So if necessary, so we've got two equations we're looking at here. If necessary, we are going to multiply one or possibly both of these equations. And the reason that we do that is so the coefficients of one of the variables, either the x or the y, will be opposite of one another. Because when we talk about elimination, that means we want something to go away. We are going to eliminate something. So we want things to be opposite because when we add opposites, they go away, right? A 3 plus a negative 3 is 0. It goes away. A 5 and its opposite, negative 5, go to 0. So after we have made sure that the coefficients of one of the variables are in fact opposites, we will then add the equations in order to eliminate, hence the method name, to eliminate one of the variables. Okay, once we've eliminated one of the variables, we can go and solve for the remaining variable that's still in the equation. So now we're going to solve for the variable that remains. Okay. Then we are going to substitute the solution for step, whoops, I'm sorry, I don't know why I did that. For step 3, the one that we did there, and we're going to put that into one of the original equations, and it doesn't really matter which one you do here, just one of the original ones. I tend to put it back into the equation that I didn't alter, that I didn't multiply by something, and then you'll solve for the other variable. Okay, so that means I've solved for one variable, then I solve for the other one. Once I do that, I write the solution as, and we remember that all the solutions for systems of equations can be listed as ordered pairs. Then we'll either check our answer in the original equations by plugging them in, or substituting them, making sure that those equations are in fact true, or again, even though we're solving these algebraically, you can graph them on your calculator. So you want to make sure that you're getting comfortable with that. One thing to note on solving by systems or by elimination is that it works best, and it's typically conducive to do this when your equations are in standard form. If your equations are not in standard form and you want to solve by elimination, you need to put them into standard form. Alright, so the rest of the notes today, we will go through 4 of our examples here. Oops, I forgot to, it looks like I forgot to erase this on your guided notes, so let's go in here. Let me just erase this. Oops. Sorry. Alright. So I'm going to erase this. Even though you've got it on your paper, I'm going to erase it so I can kind of go through it with you. You just follow along. You might even want to go out to the side and do it again, just so you're doing it on your own as well. So, all right, let me add a sheet there. So, elimination using addition. Now this is going to be special when the coefficients are already opposite. So you'll notice right here that my 4 and my negative 4 are already opposites. So what that means is we're going to add these equations up, meaning we're gonna stack them on top of one another. We're gonna add the like terms. Okay, so when I'm doing that, 4x and negative 4x give me 0, right? So I don't have anything there. Negative 3y and negative 5y give me negative 8y. 7 and 9 give me 16. I would then go on to divide both sides by negative 8 and get y is equal to negative 2. So I've now got my y answer out here, right? Well, my steps tell me that now I need to take that and plug into one of the original equations. And I'll go do that right now. Switch colors here. So I'm going to put it into this top equation. So 4x, so that didn't come out very good, did it? 4x minus 3 times whatever y is equal to, and y is equal to negative 2. Okay. And that needs to equal 7. So 4x negative 3 times a negative 2 is a positive 6. I would subtract my 6 over, get 4x equal to 1. I would divide by 4 and get x equals 1/4. Okay. In order to check this, which I won't do here because we've gone over the process of doing that in class, and you should be doing this on your own, but I would plug in 1/4 for x, I would plug in negative 2 for y, make sure that these equations do in fact equal. Okay. Or you could go graph these on your calculator and find the point of intersection, and it should be at 1/4 negative 2. Now, they're not all going to be set up exactly like that. Sometimes we are going to have to do some work prior to getting our coefficient, in order to get our coefficients to be opposites. So elimination using multiplication when the coefficients are the same. So you'll see here I've got coefficients that are exactly the same. Well, that's not quite what we want, but it's pretty easy to get there. All I need to do is make one of these negative. Okay, so here's what I'll do in order to do that. I'm going to, and this is not actually mathematically correct, but I am going to multiply that entire equation, meaning both sides of the equation, by negative 1, which is okay. I can do to one side whatever I do to the other. So that's going to require me to rewrite all of it. The top one I didn't do anything to. Minus 7y equals 29. The bottom one I multiplied by a negative 1 because I want to get that 2 to be a negative 2, because I want to eliminate it. Negative 2, that should be an x there on your notes. That should be an x. Sorry about that. Okay, so negative 2x minus y, because negative 1 times y would be a negative y. Negative 1 times 5 would be a negative 5. And now my x's will go away. I'll have negative 8y equals 24. divide both sides by -8, and I get y equals -3. Okay, so I'm going to go out here. My y value is -3. And now I'll take that y value and I'm going to plug it into this top equation, which I didn't do anything to. So 2x minus 7 times a -3 equals 29. So 2x -7 times -3 positive 21. Subtract 21 from both sides. 2x equals 29 minus 21 would be 8. So x equals 4. You can go back and check that. Alright. Alright, now the last two are going to be when I need to multiply by something other than -1. The first one we're going to show you is when we only have to multiply one of the equations. That would mean when I've already got something that has opposite signs, I only have to multiply one of the equations by a number. So you'll notice here neither one are opposites. However, this 8d is positive and this -2d is negative, so that's all I need to do is turn this -2 into a -8. Okay, so that would be what I wanted to go ahead and do here. I want to get one of these to be opposites. The 4 and the 5, I'd have to do both of them, and we'll show you that down here. Okay, so what I'm going to want to do is multiply this by 4 because I want to make this into a -8. So I didn't do anything to the top one. Plus 8d equals -16. This is going to be 20c minus 8d, and -26 times 4 would be -104. Okay. So when I add these together, those d's go away. I have 24c equals -120. And when I divide both sides by 24, I get c is equal to -5. Alright. So now what I'm going to do, plug that value into the one that I didn't do anything to. Okay, so 4 times c, which is -5, plus 8d equals -16. So -20 plus 8d equals -16. Add 20 to both sides. So 8d equals 4. That's a d there. 8d equals 4 means I divide both sides by 8, which means that d would be 4 over 8, or 1/2. Okay, so the c would come first, -5, d after that, 1/2. If you're uncomfortable with the c and the d, you can make them into x and y. These are in standard form, so it would go x first, y second, and that's perfectly fine. Might be more comfortable with that when you go to graph it as well. So, alright, we'll do one final example, then you'll be set and ready for your daily problem and to work on your practice problems next time in class. So here's what I want to look at here. I don't have opposites. Let's see. So I need to think about, I'm going to have to do something to both of these, right? So I've got two options here. One, I could do it this way. I could make this into a -10 and this into a +10, which means I'd have to take the top times 5 and the bottom times 2, right? Which that would be perfectly fine, and you would get there from that. But for the sake of showing you something, I want to show you something else. I noticed right away that 3 and 2 both go into 6. So I need to turn this into a 6 and a negative 6 somehow. Well, if they are both positive, that means I'm going to multiply one of them by a positive number. The other one I would multiply by a negative. So here's what I'll do here. I want to turn this into 6. So I'm going to multiply this by 2. I want to turn this one into a negative 6, so I'm going to have to multiply this by a negative 3. And now I'm just distributing this through. Okay, I would have 6x minus 4y equals 62. Down here, I'd have negative 6x, negative 15y, or minus 15y, and a negative 24. And then I add them together. These go away, which was the whole point, right? If you do this and then something doesn't go away, you've messed up somewhere. So you always want to make sure that something goes away or you didn't really do what you had intended. So here I end up with negative 19y equals 38. Divide both sides by a negative 19. I end up with y equals negative 2. So here's what I like to do. Do not put it in one of your altered equations. I'm going to take one of my originals, which is what it said in the instructions, and I'm going to put this negative 2 in for it. So 3x minus 2 times y, which is negative 2, equals 31. So 3x, negative 2 times negative 2 would be a plus 4, equals 31. 3x would equal 27 because I subtract 4 from both sides. And when I divide both sides by 3, I get x is equal to 9. So I would have a 9, negative 2 for an answer there. Again, really no excuse to ever miss any of these because we can check them all. Okay, you can plug these values back in, make sure they work. You could graph them on a calculator, make sure that you get the same intersection point that you got by using this algebraic method here. Go from there. Alright, I'll see you in class.